The keynote presentation will be given by Eleanor Nave of Lockheed Martin. She is a project manager for the Poland and Singapore F-35 Joint Strike Fighter program for Lockheed Martin Aeronautics. Lockheed's been a great partner of ours and a sponsor of ours, and we're just so happy that they are partnering with us on this effort. Within Lockheed, she is an alumnus of the Intensive Operations Leadership Development Program. And throughout her career, she supported 3 different Lockheed Martin business areas and 3 different unique engineering projects in 3 states around the US. And, we're just excited to hear about just her experience and how, just engineering is exciting. So thank you, Eleanor, for coming and giving our keynote.
Thank you so much. And I am absolutely thrilled to be here, especially on behalf of Lockheed Martin, where we absolutely value engineering and supporting engineering projects. So I'm just getting my presentation. So today, what I'm excited to talk to you about is engineering not only your future, but engineering our future. So how do we get there? Well, the way I structured my presentation today is I want to talk to you about my experience, an overall experience, and then how you can shape your experience using our past, present, and then heading towards that future. So let's take a journey back in time and look at STEM from the beginning. So first, let's head to the 1950s. This starts with the Sputnik era. The spark that put the US on the path to technology and innovation was the launch of the Russian satellite Sputnik into space. This year was 1957, and Americans put their competitive spirit into motion. Under the leadership of President Dwight D. Eisenhower and John F. Kennedy, Americans were challenged to step up and become leaders in science, technology, engineering, and math. Then, in 1958, we see NASA. President Eisenhower proposed the creation of the National Aeronautics and Space Administration. The legislation was signed to create a new government agency, and a space program was born. When Eisenhower left office in 1961, President Kennedy continued to push for innovation in the areas of STEM all throughout the 60s, putting the first American on the moon, among other accomplishments. So now let's go ahead and jump to the 1980s. Throughout the 1970s and the 1980s, we see a continued push that encouraged science education, and many national science programs were established to further advance the topics. The 1980s also brought about big achievements in science and technology, such as the first cell phone, the first permanent artificial heart, the first space station shuttle launch, and the first personal computer. Now, in the 1990s, we see the creation of the World Wide Web. In the 1990s, many education councils, such as the National Science Education Standards and the National Council of Teachers of Mathematics, helped guide U.S. education and educators with standards and guidelines that shape the curriculum to better prepare K-12 students in STEM. With the use of the World Wide Web and the creation, we also saw Google search engines being created that we have used to shape what we see today. Now, finally, we jump into the early 2000s. This is where I'd like to brag a little bit about Lockheed Martin as well, where we saw our first 5th generation fighter jet, the F-35. This was rolled out in Fort Worth, Texas on the 19th of February in 2006. The first flight flew on the 15th of December in 2006. The F-35 is an American family of single-engine, all-weather, stealth, multi-role combat aircraft that is intended to perform both air superiority and strike missions. Now, why do I take a look at this past and give you this general overview? I'm sure a lot of you have learned about this. Note that a lot of these initiatives did not come without failure, without prototyping, without innovation and creativity. So now I'd like to tell you a little bit about my past. Where did I first get interested in robotics and STEM in general? Well, everything started back in high school when I joined a 4-H robotics team. I was definitely a perfectionist. I love everything to go right the first time. Well, in robotics, and as you can probably see from the picture here, everything did not go right. And that's okay, because one of the biggest lessons I learned was everything isn't perfect. You continue to gather data, you continue to learn, you continue to see and reflect. Life is about continuous learning. Engineering and STEM is about continuous learning. So, what does this mean for you? What is your reflection? Well, as you continue to design, as you continue to prototype and look and see during this challenge, as you continue to fail, I was about to say, everyone's failed, right? You could definitely see in the last picture that I've failed before. But failure does not mean that it's the end of the road. Failure simply means that it's the first attempt in learning. Keep this with you as it will push you towards the future. But before we get there, let's look at the present. Technology and innovation continues to be on the rise. Unfortunately, the U.S. Department of Education states that only 16% of high school students are interested in STEM and have proven a proficiency in mathematics. Then, only 57% of high school freshmen who declare an interest in STEM-related field, they lose interest before they even graduate high school. Now, why do I say that? No, I'm not trying to scare you at all. What I'm saying is hold on to those passions, hold on to those failures. And that's how we continue to learn and grow in the present. I'd like to tell you a little bit about my present and what I learned. So here at Lockheed Martin, love to brag, currently where I am is in the Lockheed Martin Aeronautics division. So the Lockheed Martin Aeronautics division comes with tactical fighters, tactical and strategic airlift, and advanced development. But as William mentioned, I was also able to work in 2 other business areas at just my time at Lockheed Martin. I was the production quality engineer on the Mark 41 vertical launching system in Baltimore, Maryland, with our rotary and mission systems division. Now, their rotary and mission systems does more than the Mark 41 vertical launching system. They focus on radar and surveillance systems, training and logistics solutions, simulation technologies, and much, much more. Before I get to the last business area I was in, I'd like to jump over bottom left-hand side, take a look at those missiles and fire control. This is also located headquarters in Dallas, Texas, but we can see it all over the United States. This focuses in air and missile defense, fire control and situational awareness, and other nuclear missiles and solutions. Then on your bottom right-hand side, we see our corporate headquarters. This is where we focus a lot on our finance and business operations. Our leadership really runs the show from here, and this is located in Bethesda, Maryland. And the last business area I was in, space, I wanted to save for last, because especially with the solar work that you do now, we see a lot of that in our work at space. I had the pleasure of working on the Fleet Ballistic Missile Program, which it was an incredible experience. We had missiles launching into space, breaking Earth's atmosphere, and then having to calculate re-entry. Space is not just the Fleet Ballistic Missile Program, though. We also see in surveillance and navigation, global communications, human spaceflight, and strategic and defensive systems. So what does this mean for you specifically and your present? Well, at Lockheed Martin, I work with incredible engineers every single day. And don't forget, right now, you are working in STEM and you are an engineer as well. So your present is shaped by your reactions. How are you handling what gets thrown at you? The challenges, what goes wrong? How are you handling teamwork? Teamwork is crucial in especially working places like Lockheed Martin with our engineering initiatives. Innovation is key to success. As we looked through the past, we saw several iterations of creativity and innovation going through our technology. Dedication is very, very important. You have to be dedicated to a project, stick with it all the way through, from womb to tomb, I like to say, and you continue to learn and grow with the project. And obviously, stick with technology. We see technology growing, and not only is it advancing what we see today, but it's also making the world a smaller place. As you see with your competition handles all of this. And it's really exciting to see you guys preparing. So let's bring it back. We talked about the past. We talked about today's present. So how does this look towards the future? Well, renewable energy is equal to a sustainable future. What you guys do on the Solar Car Challenge is absolutely incredible. And like I mentioned, even at Lockheed Martin Space, we use solar energy on our satellites all the time. You guys are truly inventing the future. Continue to learn, continue to see everything, not just the successes, but learn from your failures. By instilling this into the current generation, it won't just be talk. It won't just be a challenge. It's reality, and it starts with each and every one of you. How is this experience going to shape your future? How are you engineering our future? Thank you so much for letting me talk to you guys today, and I'm really, really excited to see what future you have for us. Thank you.
Thank you so much, Eleanor. It's just exciting to see just the roles that we have to play in just making sure that our future is taken care of. And I think both the Solar Car Challenge and Lockheed are, paving the way for that. So thank you so much.
Absolutely, and thank you.